to be looking at trig identities. We're going to be looking at, first of all, simplifying trig expressions, and then we're going to look at trig identities. So thank you once again for joining us. I'm just going to be sharing my screen, and we're going into the lesson. All right. Okay, there we go. All right. So first of all, we're talking about proving identity. So I'm going to start with square identities, and you'll see, for those of you that are in metric, later on I'll be talking about double angle identities. And please, for those of you who are in grade 11, don't be thrown off when I start introducing that, because it's part and parcel of what you are going to have to know. So you can look at it as preparation in a sense. Right. Now, first of all, when proving identities, there are just a couple of things that we are supposed to know, at least. So one, you always try to, so you change things into sine and cos, change into sine and cos, and cos. So that simplifies things for us. We know that we'd be working with sine and cos. So something to remember is that, therefore, the tan of theta, or the tan of any angle, would be equal to the sine of that angle divided by the cos of that angle. Okay, so that's the first thing. We change everything into sine and cos. And then the second thing that we do is that we always try to find the lowest common denominator. All right. In this case, it means that we are going to try and remove fractions, or let me rather say resolve fractions. Okay, so by finding the LCD, and in this case working through the fractions. And then thirdly, okay, what we're going to do also is just make sure all the time. So I'm giving you the procedures, and you'll see me apply this as we go along in the questions that we're going to actually have, right? So the third thing that we're going to do is try and resolve brackets. Okay, so if we've got brackets, we try and resolve that to try and simplify as resolve any brackets. Okay, and now another important thing that we do is we always try to work with okay, let me try and get rid of this. Okay, sorry about that, guys. I don't know why this happens every time when we're in the midst of a lesson, but anyway, so in this case, what we're simply saying is we resolve brackets, and then what we will always try to do is in this case try to work with square identities, and which I'm going to mention right now. So square identities, we know that if you have the cos squared of theta plus the sine squared of theta, this is equal to 1. Please be very careful, right? Cos squared of theta plus sine squared of theta, this is equal to 1. But there are times when you are perhaps given cos squared of theta, and you might have to substitute it with 1 minus sine squared of theta. So all I've done is just take the sine squared of theta to the other side. So cos squared of theta is 1 minus sine squared of theta. Now, if you look at this, this is what we call the difference of two squares. One is a perfect square, right? And sine squared, of course, is a perfect square. So how do we factorize a perfect square? Sometimes we might need to factorize. So we would have 1 minus the sine of theta, and 1 plus the sine of theta. Of course, I'm going to give you procedures as we go along. For now, these are things that I just want you to know. And of course, just like we said, you might have sine squared of theta and may need to substitute it with 1 minus cos squared of theta. And once again, you'd have 1 minus cos of theta, and in this case, 1 plus cos of theta if you want to factorize it. This is how we always factorize the difference of two squares. Ladies and gents, before I continue, are there any questions? Okay, right. Should I assume that everyone is okay?
Yes, sir.
All right, beautiful stuff. All right, now what I'm going to do is, in fact, let me do this. Before I go to the other ones, I thought let me take these ones and let's try to do it together, né? And obviously afterwards we will then go to the more complex type of examples. All right, so we've got an identity here. So first of all, they're saying to you, now when there's no equal sign, they can't say prove the identities. But what do they say? Simplify the expressions. The very same process that we use for simplification is the very same process we'll use for proving identities. The only thing with proving identities is that at the end of the lesson or of the sum, what we simply do is just to make sure that we say left hand side, or rather we must make sure that left hand side is therefore equal to right hand side. All right, now let's take the very first one, né? And this session is going to be a bit interactive because I'm going to choose at random any of you, that are going to try to, and you're going to try to help us to find the right answer, right? Okay, now let's start with the first one. On the first question, we've got cos squared of alpha over sine squared of alpha. So I'm going to write it down at the bottom there. So we've got cos squared of alpha over sine squared of alpha. This is into, we've got 1 over cos squared of alpha minus 1. 1 over cos squared of alpha minus 1. All right, now, what we said, first of all, whenever we are trying to simplify expressions, we're going to try and resolve everything into sine and cos. I see on this one, we already have everything in terms of sine and cos, right? Now, we said procedure number 2. What we need to do is we're going to resolve all the brackets. We're going to resolve all square identities, right? Now, what I'm going to do is allow me, in this particular case, to say, look, let me leave this on the outside as is. I'm going to have cos squared of alpha over sine squared of alpha, right? Now, inside the bracket, I see I have got, in this case, a fraction and a whole number, right? So when you've got a fraction, in this case, what we simply do, how can I write 1 in such a way that it's a fraction with cos squared of theta? Do you agree with me that it's the same as having cos squared of alpha, rather, over cos squared of alpha? Do you agree with me that this is equal to 1, right? So I'm going to write this guy as, so I'm going to have, 1. So I'm going to have 1 over cos squared of alpha minus cos squared of alpha over cos squared of alpha. Now, why am I doing this? Remember, you cannot add fractions that do not have the same denominator. So I'm trying to get my denominators in the bracket to be the same. Okay, so now I see there, now my denominators are the same, right? So I can add the numerators. So in this case, I've got cos squared of alpha over sine squared of alpha, right? Now, in the bracket, what do I have? I've got 1 minus cos squared of alpha divided by, now I can add the numerators together, right? Because my denominator is the same. So that's cos squared of alpha. All right. Are we all together so far?
Yes, sir.
Right.
Yes,
Beautiful
sir.
stuff. Okay. So I see at the top, what do we see there? We've got an identity, isn't it? 1 minus cos squared of alpha, that's one of the square identities. So we've got cos squared of alpha over sine squared of alpha multiplied by, now 1 minus cos squared of alpha, you remember that's one of the square identities that we had, right? This is equal to sine squared of alpha over, in this case, this is going to be cos squared of alpha. All right, I'm sure many of you can already see what's going to happen here, right? So what are we going to do? It means this guy cancels with that one. It means this guy cancels with that one. And what are we left as our final answer? Our final answer will therefore be 1. Okay, so we'll be left with just 1. Does it make sense, ladies and gents?
Yes.
I'm sure many of you maybe
Yes,
might
sir.
have a question and wondering, but what if I had multiplied into the bracket? You know, what if I had multiplied cos squared of alpha over sine squared of alpha? There's nothing wrong. We can actually try that. Né? Let's see. So what you are going to have, okay, I'm just going to try and make some space here. What I was going to have was, if I multiply into the bracket, okay, right, let's start here. So cos squared would cancel the cos squared there, so you would end up with 1 over sine squared of alpha. In fact, you know what, let me just show it so that I don't confuse you. So I would have cos squared of alpha over sine squared of alpha multiplied by 1 over cos squared of alpha, right? And then we've got the minus sign. And then if I multiply, remember we use our FOIL method, right? If I multiply into the 1, so what do I have? I would have cos squared of alpha over sine squared of alpha, right? And you see the beauty about proving or simplifying expressions in this case is that you always, even though you can take different routes, you end up at the same place anyhow, right? So what I would have there is that I see that cos squared would cancel the cos squared. So on the left hand side, or rather on here, I'd have 1 over sine squared of alpha minus cos squared of alpha over sine squared of alpha. Now, if you look at this, my denominators are the same, so I can add the numerators together. I'll have one common denominator, so I'll have 1 minus cos squared of alpha divided by sine squared of alpha. But then, you see we've got a square identity again. Né? So 1 minus cos squared of alpha is sine squared of alpha over sine squared of alpha. And guess what? This would again give us 1. Okay. I'm not sure which one you prefer between the two. I think the second one was a little bit easier, I must admit. Okay, right. But either way, you still get to the same answer. All right, let's go to the second one very quickly. We've got 10 squared of beta, 1 plus 1 over 10 squared of beta. So 10 squared of beta into 1 plus 1 over 10 squared of beta. All right. Now, it's really up to you. If you want to, let's multiply into We said we change everything into sine and cos. We can't do that. But in this case, what I'm going to do first is just multiply into the bracket. So I'll have 10 squared of beta. Okay. And I multiply the times 1. And now for this one, I'll have 10 squared of beta multiplied by 1 over 10 squared of beta. Okay. Now I'm sure you can already see how this will give us, these cancel with each other, and we will get 1 as our final answer. All right. I mean, as the final product here. So I've got 10 squared of beta plus 1. Right. Now, of course, what did we say? We resolve everything into sine and cos. So what is 10? 10 is sine squared of beta. So 10 is sine over cos, but because we squared it here, it would be sine squared of beta over cos squared of beta. Okay, plus 1. But exactly what we did in the previous one, we said, look, I've got a 1 there. How can I write it in such a way that it has a denominator of cos squared of beta? So this would be cos squared of beta divided by cos squared of beta, right? So I'm writing it as a fraction that has a denominator of cos squared of beta. So in this case, what would I have? I'd have sine squared of beta over cos squared of beta, right? Plus cos squared of beta over cos squared of beta. Right, my denominators are the same. So what can I do? I can simply add the numerator. So I've got cos squared of beta. That's my denominator. But at the numerator, I've got sine squared of beta plus cos squared of beta. Now, I'm sure you can already see what that is, isn't it? We've got a square identity. And what is that square identity? That would give us 1 at the top there. So I end up with 1 over cos squared of beta. That's the simplest form I can get it into. Are we all together, ladies and gents? Please tell me if I'm going too fast. And obviously, I'll try to scale down the pace. Are we good?
We good, sir.
Yes, sir.
Awesome. Welcome, Maschab.
Thank you, sir.
All right. So, now what I'm going to do now, if we look at it, so the next one, right, I'm gonna pick on one of you. So we've got 1 over sine squared of theta. Okay, sorry about that. So we've got 1 over sine squared of theta into, I think that was 1 over cos squared of theta minus 1. All right. Is there any volunteer who would like to take me through this one? Should I choose one? Okay, let's choose Buhle. Hello, Buhle. Okay, are you still around? If you're with us, please unmute your mic. All right, it seems Buhle is having some challenges. Are you still with us?
Yes, sorry.
Okay, awesome stuff. Awesome stuff. Right. Can you please take us through this one? What would we do?
Okay, so in the brackets, right?
Mhm.
I would change the 1 into cos squared theta over cos squared theta.
Okay. So I leave this one as is. So in the bracket, you're saying let's change this one into cos squared of theta over cos squared of theta. Uh-huh.
Then I would write the fraction in the bracket as 1 minus cos squared theta over cos squared theta.
Okay. So that would be 1 minus cos squared of theta divided by cos squared of theta. Okay.
Then I change the 1 minus cos squared theta into sine squared theta.
All right. We've got ourselves a square identity. So that would be sine squared of theta over cos squared of theta. That's inside the bracket. Ne? So we still have 1 over sine squared of theta here. Yes.
Then I'd cancel the sine squared theta, and then the final answer would be 1 over cos squared theta.
All right. Those cancel out. And so our final answer would be 1 over cos squared of theta. If we could, we would give you a big, big, big round of applause right now. Okay. Very well done. All right. Now, this is in terms of simplifying identities. And please, not simplifying identities, rather, simplifying trig expressions. All right. Now, we're going to go into the next part now, where we are just looking at identities. Right. And I want you to remember this, that whether we are simplifying expressions or whether we are proving identities, the process is the same, right? The only difference here is that we are working with two sides, left-hand side and right-hand side, and we're trying to make sure that at the end of it, we've got left-hand side equal to right-hand side. Okay, so I'm just going to do this for the sake of, being able to work with this more easily. Right, now, the second portion says prove the following identities are true. Prove that the following identities are true. So, right, so the first one, we've got 1 minus sine to the power 4, or rather exponent 4 alpha, which is equal to cos squared of alpha into 1 plus sine squared of alpha. Now, please do not get, don't dismay and think, yeah, but hey, I don't even know where to start. Okay. So in this case, remember that the identities that we have to do with sine. They are square identities, né? So please, under no circumstances, don't change this into cos. Uh, um, you know, to the power 4 of alpha, right? So in this case, what we're simply going to do is try and work on both sides. So what you do, we're trying to prove left hand side equal to right hand side. Okay, let's draw a line there and see how we can get them to be the same. Hey, my line is not that good. Let's try. There we go. Right. Tina. Okay, Ucina has run away. Bunolo. Is Bunolo with us?
Yes.
Okay. Right. Bunolo,
Yes.
what would you want us to do here?
Okay. So we can start by using the FOIL method, as in clearing out the brackets.
Okay, beautiful stuff. So we leave left-hand side as is. So this would be 1 minus sine 4 of alpha. And so we're going to multiply in there. So you're saying we should say cos squared of alpha times 1 will give us cos squared of alpha, right?
Yes.
Plus, we've got sine squared of alpha times cos squared of alpha. Okay, right?
Mm,
Mm. Okay, so let's
Factor
compare
out
left.
cos theta.
Say that again.
Sorry,
Yes,
I was just saying they should factor out cos squared theta.
but then we would be going back to the very same thing that we had. You see,
Oh yeah, that's true.
yeah. So we'd be going back to what we already had. Now, in this case,
Oh, wait. Okay.
can I suggest something? Oh yeah. Go ahead. You wanted to say something.
Yes. So with. Okay, never mind.
I do mind when man. How? Okay.
Okay.
So look at the left hand side. What does it have? 1 minus sine square sine to the power 4 of alpha. Ne? Is it possible to write this, the right hand side, in such a way that you end up with something that kind of looks like the left hand side? Now think about it. Can I write cos squared of alpha in such a way that it has sine in it? Yes. And what is it? It's 1 minus sine squared of alpha. Right? So this guy here can change into 1 minus sine squared of alpha. And this one, 1 plus sine squared of alpha. Isn't that true? Right?
Yes, it
So,
is, sir.
So in this case, now what I can do is now apply the FOIL method again. Of course, this is the difference of two squares. And please, I don't want you to waste time. Remember, whenever I've got two brackets that are exactly the same, but with different signs, okay? This is what we call the difference of two squares. So in this case, if I've got a plus b, a minus b, I'll end up with a squared minus b squared. And do we know why? Because remember, if I take a times a, that will be a squared. But if I take a times b, that will be minus ab. If I take a times b, that will be plus ab. And b times b, positive times a negative will be a negative. So I'll end up with minus b squared. So these two cancel out because they're exactly the same. So you end up with a squared minus b squared. So remember, whenever you have the difference of two squares, you know, you can always factorize it in such a way that you've got two brackets that are the same, but only with different signs. Okay. So in this case, I've got exactly that. Yeah, man, I'm erasing stuff here. Right, I've got exactly that. So I will have, in this case, this would be 1 minus, if you notice, this is going to be sine to the power 4 because sine squared times sine squared will be sine to the power 4 of alpha. So therefore, what do I note? Left-hand side is definitely equal to right-hand side. Are we all together?
Yes, sir.
All right, beautiful stuff. Okay, the next one, we've got 10 lambda, 10 times cos, so that's 10 lambda. They say prove that it's equal to the sine of lambda. Okay, let's see. Who can we pick? Nosipho.
Yes, sir.
Take us through this one.
You.
Utiyo. Right, remember, what's the first thing that we do? Always try to change into?
Oh, sine cos. So the 10 lambda, we change it into sine lambda over cos lambda.
Correct. Over cos of lambda. Okay. This is times cos of lambda. Okay. We are listening.
And then we, what's the word? Cross out both causes.
Yeah. So in this case, those two will cancel out, né?
Yeah.
Because that divided by that would give us 1. So we've got sine of lambda on the left-hand side as well as right-hand side. So we can say, therefore, left-hand side is equal to right-hand side. Okay, very well done. Very well done. All right. The next one, I want us to just finish these ones and then we are going to go into double angle identities. Obviously, we're just going to ramp up the temperature a little bit. So if you find yourself sweaty, it's because it's worth sweating for. Okay. So we've got cos of alpha over sine of alpha. So let's write that one down. Cos of alpha over sine of alpha multiplied by 1 over cos squared. 1 over cos squared of alpha. Okay, and we're trying to prove, times sine squared of alpha. Times sine squared of alpha. Times sine squared of alpha. And we are trying to prove that this is equal to just simply 10 of alpha. All right, Ashley. Are you still awake?
Yes, sir.
Oh, beautiful stuff. All right, please take us through this one.
So I would cancel cos. No, first I would change sine squared of alpha into 1 minus cos squared of alpha.
Say that again. So you're going to change what?
Sine squared alpha into 1 minus cos squared alpha.
Okay, let me give some advice here, Ashna. Is there obviously we would do that because we would do that with an intention. So remember, every time that you are looking at identities, always keep in mind what's on the right hand side. You've got 10 of alpha there, right? And if we wanted to write 10 of alpha, we could write it as sine of alpha over cos of alpha, right? Now, I know we've got square identities here, but before you go into square identities, do you see that you've got fractions, né? cos over sine. Not that what you probably would have gotten to it, but the long way around. Okay, so I'm trying to just show you a quicker method here. So you have, in this case, if we multiply all of them together, this is over 1. So 1 times sine squared would give you sine squared of alpha, right? And 1 times cos squared will give you cos squared of alpha. Now tell me something that you see, Ashley. If I had x over x squared, what would I get?
You would get x.
Okay,
1x.
note. So that x, now it means that what do I have? I have x over, how do you get x squared? It's x times x, isn't it? Now notice, one of those x's would cancel one of the x's, right? So those would cancel. So what would I actually have? 1 over x, isn't it? Do you get that?
Yes, sir.
Okay. Now, I'm trying to show you in this case that, so, and this is for all of us, né? So you've got cos of alpha and you've got cos squared of alpha. So one of the causes here, right, would cancel one of the causes in your square so that you're only left with what? Just cos of alpha without the square. Same thing with sine. That sine would cancel one of the squares there. So what do you end up having rather? You'll end up having sine of alpha because one of them has been cancelled, so you're left with only one, divided by cos of alpha. What do you notice, Ashley?
Left hand side is equal to right hand side.
Beautiful stuff, my dear. Right, left hand side is definitely equal to right hand side. Okay, happy days, ne? Right, the very last one in this section, and then what we're going to do is obviously just jump into the other examples. And please remember, everything still remains as is. Let's see. So cos, you know what? I'm just going to remove this so that I just don't keep jumping around, trying to find the equation. Right. So we've got cos, right, cos power 4 of beta over sine to the power 4 of beta, got cos squared of beta over sine squared of beta. This is equal to 1 over sine 4 of beta minus 1 over sine squared of beta. All right, now, right, who can take us through this one? Maschal.
Hello, sir. Yes, I am here. I don't even know where to start.
Right.
You're okay. So I'm looking at the right hand side. I'm trying to see actually what is it that I can change.
Mm-hmm.
Okay. Mm. But what I would, oh no, it won't work. Yo, sir.
It's that yo for me. Yes.
So I'm trying to think as quick as I can, but I can't. So
Okay.
okay, so on top for both, okay, let's change the left-hand side rather, not the right.
Okay.
So if I were to change the left-hand side, so I want to be left with one, both one for both the numerators. Right? True, Mujimu. Okay, I'm trying to think fast and I'm panicking, and yeah, I can't get anything right when I'm like that. But then let's
Okay.
change the left-hand side.
The left-hand side, okay?
Yeah. So the left-hand side, both the denominators we're not changing. Mara re tlo
Okay.
change,
Right. So do you realize we've got fractions, ne?
we do have fractions, yes.
We do, ne? So why don't we try and just deal with those fractions? Okay?
Okay, right.
All right. Let's deal with the fractions. So remember, when you deal with the fractions, you always have the lowest common denominator, isn't it?
Yes, the lowest common denominator. Yeah,
Yeah.
that's right.
Now, the thing about it is that, and this is something, a trick that I want you to learn, please. Right?
Yes, sir.
Which one will be the lowest denominator here?
Sine squared beta.
No, actually, it will be the one with the higher power. Okay. Now,
Okay.
just taking you through, and by the way, this is a lesson for all of us, ne? For all of us. Because I know this is not one of those things that people don't know, or rather don't remember very easily. So if I have 1 over x plus 1 over x squared, and I'm looking for the LCD, right? Now, you'll always take the one with the higher power, in this case, as your LCD. So what I'll say is that my LCD would be x squared, right? Now, please, I want you to listen carefully. Remember, when I now make it into a fraction, I always say LCD divided by my denominator, and the quotient of it I multiply by the numerator. So x squared divided by x will give me,
You'll get x.
you'll get x. X times 1,
It's x.
correct. You see? And then let's do the same. So plus, which is that one over there, right? X squared divided by x squared will give me
It will give you 1.
1 times 1.
It's 1. Okay.
So it means there's my fraction.
Okay.
Okay. Happy days, ne?
Happy days. So in this case, we're
Alright.
going to make sine to the power
You
of
see,
4 beta.
I love it when you see it immediately. You can't even wait. Right. So what's my LCD?
Okay, so LCD more, it's over sine to the power of 4 beta.
Correct. Right? Now let's deal with our fraction here. Right? So we know that our denominator is therefore going to be sine to the power 4 of beta. Yes. So LCD divided by denominator, we get,
So LCD divided by the denominator. Sorry, I'm a bit lost. LCD divided
there's
by
our
our
LCD.
right.
Divided by that denominator,
it's 1.
it's 1. 1 multiplied by cos
By
to the power
cos
4 of
4
beta.
is cos to the power 4 beta.
Correct. All right. Awesome stuff. And then we've got a plus sign. There it is there. And then let's do the same. Sine to the power 4 of beta divided by sine squared of beta. What do we get?
Sine to the power 4 divided by sine squared. So we are going to get sine squared beta.
Okay. So we're going to get sine squared. Sine squared multiplied by cos squared.
Is sine squared cos squared.
Correct. So we're going to have cos squared of beta. Sine squared of beta, cos squared of beta. Very well done. Very well done. Okay, right. So let's try and work with it. So what can we do at the numerator?
So we have a common factor there, which is cos squared. No, we don't actually. Just as,
We do.
sorry.
You're right. You're absolutely right.
Yes, sorry. So we can factor out cos squared beta.
Okay, cos
So cos
squared
beta, open
beta.
bracket, and
Uh-huh.
open bracket. So we'll be left with cos squared beta also, again, plus sine squared beta. So be left inside the bracket,
Okay.
all over sine to the power of 4 beta.
Uh-huh. Hey, we are heading somewhere, ne?
Yeah, we are trying to head somewhere.
Okay.
So what I
Come
so what
on, come on. This guy here. What is it?
So that, yes, that's an identity. So you can simply write
Correct.
one more.
Yeah, sure. So at the top, we've got cos squared of beta, but we know this guy already gives us 1, right?
Right.
Okay. So that would be the same as multiplying by 1, which would give us cos squared of beta, isn't it?
Yes, sir.
Over sine.
Sine to the power 4.
Okay. Happy days, ne? Right.
Yes,
Do you
sir.
still want to do anything else here?
Clarion. So what was supposed to be the answer? The answer is supposed to be 1 over sine to the power 4 and minus 1 over no. So now what I would do,
Yes.
So I would change the cos squared to 1 minus sine squared beta.
Okay. You know what we should do, ne?
Okay.
I think we've done what we could with the left-hand side. What do you think?
Okay.
Now, there are exceptions where you find that you might need to work with left-hand side and immediately after then work with the right-hand side to get them to be the same. This is one of those exceptions. Okay.
Oh, okay. Yes.
Aha. So now let's do that. So let's work with the right-hand side. Right-hand side is also a fraction, isn't it?
Yes, sir.
Okay. Minus 1 sine squared of beta. I'm sure everyone has respect for you. Would you? I'm glad it's not me.
Yes, and I was hoping you were not going to pick me.
Right. Okay. Let's continue. So what can we do on the right-hand side?
Okay, so we want the right-hand side to be exactly like the left. So where we left the left, the left, where we left the left.
Yeah. No, I hear you. English.
Yeah. It's not nice. Okay, so if I were to say, I would change that one, the numerator. So the first part, let's change the numerator to.
And let's deal with the fractions.
Oh yeah.
You see, the thing is, every time when you've got those fractions, please, try and resolve fractions. Okay.
Right. So yes,
Right.
sorry about that. So the lowest common.
No, we're learning, it's the process of learning. Right.
Okay. So we agree that the lowest common denominator between the two will be the one with the highest power. So in this case, it also.
Wonderful. Yes.
So our denominator will be sine to the power of 4 beta, right?
So 4 beta. Okay,
And
so that's our LCD, ne?
Our LCD. Then we're going to say LCD divided by our denominator is going to give us 1. Multiplied by 1, still 1. So we're going to have 1 there.
1.
So, right. So we go to the other side. We take the sign. Let's take the sign. So we take the sign down. And then sine to the power of 4 beta divided by sine squared beta will give us sine squared beta times 1, which is sine squared beta.
Aha. I think we're getting somewhere. What do you think?
Yes, we are. So we're gonna change that
Ah.
identity. So we're
Aha.
gonna change that identity. So we're gonna have the one on top, our numerator, it over cos squared beta divided by sine to the power of 4 beta.
Ish. Where Nana?
Naman.
What can we say?
I can safely say our left hand side is exactly the same as our right hand side.
Correct. All right. So my point with this one is that there are times when you might have to work with both the left and the right to get them to be the same. Okay.
Okay,
Please,
so
ladies and gents, what I ask is that when you find that you've got a fraction, always try to resolve fractions. When you've got brackets, try and get rid of them. Okay. You know, so when you've got powers, you know, try to deal with those and so on. Okay. So that will actually help us to actually get to you know, proving rather the identity. All right, are we okay, ladies and gents?
Yes,
yes,
sir.
sir.
All right,
Yes,
happy
sir.
days. Now, you remember I said there was a point where I was going to be this mean guy, ne? That you would not necessarily like. I think this is the point. So I want us to prove identities, but this time around, what we're going to do is we are going to now add what we call double angle identities. Now, I want to just begin by just taking you through what we call double angle identities and also what we call compound angle identities. Now, this is relevant. Compound angles are relevant for both grade 11 and 12, but double angles are specifically for grade 12. Okay. However, you know, for me, you would have lost nothing as a grade 11 if you know about double angle identities. Anyway, I want you guys to be prepared to start writing the NPT exam. Okay, now, first of all, don't worry about the exercise. Ne? We'll come back to the exercise. Now, we've got what we call double angle identities. Now, for double angle identities, what we have is, let's start with sine. Okay, let me just remove that. So we've got sine of 2a, all right? It could be a, it could be theta, it could be anything, right? So sine of 2a would be 2 sine of a cos of a. Please keep that in mind. Nah? Now, the double angle of sine is really simple and straightforward. It's this one for cos of 2a that is not as straightforward. Okay? So cos of 2a would would give me, notice this is cos squared of a minus sine squared of a. Please, ladies and gents, I ask you to be very, very careful on this one. There's a difference between cos squared of a minus sine squared of a and this guy. Cos squared of a plus sine squared of a. This one is equal to 1. You remember that, ne? This is a square identity, right? But the double angle identity for cos, okay, in this case is cos squared minus, sine squared of a. Now we can write it in this way. We can also say, well, but we know that we can have cos squared of a. We can write sine squared as 1 minus cos squared of a. And what that does is that we end up with 2 cos squared of a minus 1. Now, I'm going to give you tips as I go along. Ne? Just stay with me. All right. But you can also write it by changing cos squared of a into 1 minus sine squared of a. And what you end up with is 1 minus 2 sine squared of A. So once I have cos of 2A, usually A, man, it's not really a nice thing, né? But we will always try to find, to find an answer. All right. Now, something else that I want you to also note, okay? Because I'm going to give you some exercises, né? Cos squared of A minus sine squared of A. Do you realize once again that you've got the difference of two squares, right? So you can factorize this guy to becoming cos A plus sine A into cos A minus sine of A. All right. So you can actually, simplify, or in this case, factorize that guy. Now the thing about it, because sine 2A, once you've got a sine of a double angle, no problem. You cruise, né? You cruise nicely. But cos A, you need to think a little bit before you substitute. And there are just a couple of guidelines, and you'll see in the questions that we're going to take, we'll take it one guideline after the other, okay? And I'll show you what you would need to consider in the particular example, okay? Right. I hope all of us are okay with this. All right. Now, just another thing that we just need to remember, we've got what we call compound angle. And by the way, double angles come from compound angles rather. So what it says is that if we've got cos of A plus B, right? So cos A plus B will be equal to cos A cos B. Now, please note, when I've got a plus sign for cos, then it changes the sign, it becomes negative. So this will be minus the sine of A sine of B. Okay, so cos A cos B minus sine A sine B. Of course, if you've got a minus there, if you've got cos A minus B, then this just changes to plus. Okay, right. So you just change the sign. Now, when you've got sine of A plus B, this becomes sine of A cos of B, but this does not change sign. Okay, so it becomes sine A cos B minus sine B cos of A. The angles kind of interchange, né? Okay, so on the sine, the compound angle for sine, it remains as is. If it's a plus there, it becomes a plus. If it's a minus, then it becomes a minus. Are we together, ladies and gents?
Yes, sir.
All right. Now, before I become the guy that you like the least, let's try and work through these ones. Again, we are proving identities, né? But easily it could have been an example of simplifying identities. So we're going to say, well, look, we've got cos of x plus tan of x, sine of x, and they're saying we should prove that all of this is equal to 1 over the cos of x. Now, let's do what we need to do. What did we say the first thing that we need to do is? We resolve everything into sine and cos. Okay, so let's start there. So I'm going to work with the left-hand side. Okay, ooh-wee. That was supposed to be a straight line. Okay, right. Now, on the left-hand side, I'm just simply going to say, well, we've got cos of x plus I see there I've got 10x. So let's resolve that into sine x over cos x times sine x. Okay, now let's work with what we have there. So we've got cos of x plus, now if you look at this, so we've got sine, remember this is the same as sine over 1, right? We are multiplying fractions, so numerator to numerator, denominator to denominator. So this is going to be sine squared of x over cos of x. Remember, cos x times 1 will simply become cos of x, right? So what do we do this time around? Remember, we said we try to resolve fractions as much as we possibly can, right? So what's our LCD? Our LCD is going to be the cos of x, right? So again, so this is the same as over 1, right? So I'm going to say LCD divided by denominator, so cos x divided by 1 will give me cos x, multiplied by cos x, this will be cos squared of x. Are we all together, ladies and gents?
Yes, sir.
Okay. So you've got cos of x divided by cos x, which will be 1, multiplied by sine squared of x, that will give us sine squared of x. And well, guess what? We've got cos squared of x plus sine squared of x. This is equal to 1. And we've got 1 over cos x. And what do we notice again? We've got left-hand side equal to right-hand side. Okay, right. Let's move along very, very swiftly. Ne? Right. So let's take the second one. I kind of want to. Okay, let's take the second one. 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 Okay, so we've got sine theta over 1 over cos theta. So we've got sine of theta over 1 minus cos of theta. And we have minus cos over sine minus cos theta over sine of theta. And we must prove that this is equal to 1 over sine. 1 over sine of theta. Right. So, should I pick someone? Let's see who hasn't participated as yet. Yeah, Uratilwe.
Hello, sir.
Hi, Uratilwe. How are you?
I'm okay, and you, sir?
I'm fantastic. Thank you for asking. Right. Talk to us.
Well, we have to find an LCD. That's
Okay. So we're gonna work on the left-hand side, ne?
yes, the left-hand side.
Okay. Right. So in this case, from the left-hand side, what is our what is our LCD?
1 minus cos theta times sine theta.
Yeah, definitely. Definitely. There's nothing common between those two. So in this case, we just need to take both of them, right? 1 minus cos theta times sine of theta. Yes.
And then it's sine squared theta
Yes.
over sine squared theta minus.
Okay. First of all, I need to remember we say LCD. Here's our LCD. divided by the denominator of the first fraction, right? So do you agree with me that so what would happen here? Okay, I just want to put this thing over here. Right. What would happen here is that if I divide this guy by that guy, what happens is that these two will kind of cancel. Do you agree?
Yes, sir.
So what will I be left with in the LCD? Sine of theta, right?
Yes, sir.
So sine of theta multiplied by the numerator, okay? So that would be sine theta multiplied by sine theta, and that would give me?
Sine squared theta.
Correct. Okay, I'm trying to just remove this here. So that would be sine squared of theta. I hope you guys are getting this. Please, if you feel a little lost, please do shout now. Are we all okay?
Yes, sir.
Yes, sir.
All right, beautiful stuff. Okay, so that would be sine squared of theta minus, so there's that minus sign there. Okay, again, we are going to take LCD divided by the denominator. So what happens? It will be sine canceling that other sign. What am I left with? Okay, I'm left with 1 minus cos, right? So in this case, it will be that cos theta times 1 minus cos theta. Are you okay?
Yes, sir.
All right, beautiful stuff. So, Uradilwe, please continue.
Mm. Can I cancel the 1 minus cos theta?
No, not yet. Not yet.
Okay, then it's sine squared theta minus cos squared theta over 1 minus
Yes,
cos
yes,
theta
yes.
times
So
sine
let's
theta.
multiply into the bracket. Ne? So we'll have sine squared of theta. So this multiplied into that will be minus cos of theta. Okay. But remember, negative times a negative will give us a positive. So this will be plus cos squared of theta. Do you see that?
Yes, sir.
Okay, guys, do you see it? Remember,
Yes, sir.
once I multiply those negatives, they become a positive, right? And then obviously this is divided by 1 minus cos of theta and sine of theta. Okay, right. So let's try and resolve that again. What do you notice there?
There's an identity.
Ah, beautiful stuff. Tell us.
The sine squared theta plus the cos squared theta will give us 1.
Correct.
So it'll be 1 minus cos theta.
1 minus cos theta over I'm sure you're seeing it now, ne?
Yes, sir.
What happens?
We cancel the 1
Right,
minus
so
cos
now
theta.
this can cancel that. We're left with a 1. So that will be equal to 1 over sine theta. Uratile, what can you say now?
Left hand side is equal right hand side.
Beautiful stuff. I'm sure the others are so relieved on your behalf, eh? They're thinking, shoo, yeah, she pulled it. Okay, right. Guys, do we all get it?
Yes, sir.
Yes, sir.
All right. Now, what I wanted us to do, perhaps I'm going to just skip the others. Ne? I just wanted to rush to the ones that seem to have double angles in them so that we see how to apply that there. Would it be okay if I skipped D? Actually, C, D, maybe let's take E. Is that fine?
Yes, sir.
Yes.
Okay, right, let's take E. So 1 plus 10x and 1 minus 10x. So I've got 1 plus 10x over 1 minus 10x. Okay, and they wanted us to prove that this is equal to 1 plus 2 sine x cos x and cos squared of x minus sine x. Okay, they want us to prove that this is 2 sine x cos x. 1 plus 2 sine x cos x, sorry. 2 sine x cos of x, and this is divided by cos squared of x minus sine squared of x. All right. Now, all right, for the sake of time, we don't have a lot of it now. What I'm just going to do is just go through it with you. Right. So I want you to please note in this case, what are we going to do? We're going to now work with, of course, we change everything into sine and cos. Sine x over cos of x, right? Divided by 1 minus sine of x over cos of x. Now, there are two ways in which you can do this, all right? It's really up to you. If it was me, I see I've got two denominators that have cos x in them. So I could multiply the top by cos x, but what I do at the top, I also do at the bottom. Okay? Oh, say, but how do you know that? Look, you could have also done it the normal fraction way. Okay? It's just that this one is much more easier or much quicker. Okay? Otherwise, I'm just showing you what you could have done. You could have done, well, taken LCD at the top. That would have been cos x, and that would simply be LCD divided by denominator multiplied by numerator. So that would be cos x plus sine x divided by, which is this division line here, again, cos x minus sine x divided by cos x. I hope you guys know that when you've got two fractions with the same denominator, for instance, if I have 1 over 4 divided by 3 over 4, you see that the denominators are the same, right? So I can drop down the denominators, and this fraction would simply be equal to 1 over 3. Okay, so that's what I would have done there. I would have dropped down those denominators. I've got cos x sine x, and I've got cos x minus sine x. Okay, but what I chose to do was to multiply the top and the bottom. Yo, guys, I wish we had all the time in the world. Yes, yeah, really, I feel like these sessions are so short. Anyway, we multiply there by cos of theta, cos of x. That will give us cos x. If I multiply by cos x here, it cancels, the cos x's cancel. So I'm left with just sine of x divided by, same thing, cos x times 1 would be cos x minus the cos x's would cancel here, and I'd be left with the minus sine x. Okay, right. Now, you can choose here whether you want to continue and work through this one, or you want to go to the right hand side and try to make it into something that's a little bit more user friendly. Let me just show you something there. All right, now you remember I said to you sometimes you might need to work with, now please I want you to listen carefully. I can change that 1 and make it into cos squared of x plus sine squared of x. Do you agree that I would have changed nothing? I took the 1 and made it into the expanded form of the identity. This is plus 2 sine x cos x. Okay? Right. Now, this is divided by cos squared rather of x minus sine squared of x. I see that I've got double angle, not a double angle rather. Yeah, it is a double angle identity. But in this case, what I can do is I've got the difference of 2 squares. Okay? And that's because I'm looking at the left-hand side. So I've got cos squared of x plus 2 sine x cos x plus sine squared of x. Right? Do you agree with me? I didn't change anything about the top part, ne? Cos squared of x minus sine squared of x. You're probably wondering to yourself, what on earth is this old man doing? Right, now I want you to please note, if I have got a bracket that is a squared plus 2ab plus b squared, is it possible to factorize this? Absolutely. And what does it become? It becomes a plus b all squared. Or you can just simply say a plus b, a plus b. Okay? When you expand this, you get that. Now, I want you to note your numerator. You've got cos squared plus 2 sine x cos x plus sine squared. So what you can do is factorize that and make it cos x plus sine x squared. Okay? And this is divided by, you remember when I talked about the difference of 2 squares? At the bottom, you've got cos x minus sine x divided by cos x plus sine x. The difference of 2 squares, right? So cos x plus sine x cancels out with one of those cos x plus sine x there. So what do I end up having? Cos x plus sine x divided by cos x minus sine x. All right. And what can I conclude? Left-hand side equals right-hand side. Are we good, ladies and gents?
Yes, sir.
All right. Now, for the sake of time, I did send you this on the group. So please just have a look at the rest of them. Sorry that I couldn't touch on those double angle identities as much as I could have, as I wanted to. But what we can do is just maybe have a consolidation session, with the matriculants and all of you grade 11s, just to make sure we polish up on those few things. Maybe on the last day, we'll see what we can do about that. Okay. Right. I want to leave this lesson here, and I'm hoping that you did gain a lot, that it did help you, all right, on how to work with identities and simplification of trig expressions. All right. Yeah. So we'll meet again tomorrow. Ne? Let's see. Please, guys, I'm asking yet again, try to be on time. Check your links maybe 30 minutes before, And please try to log on. I'll always try to log in 5 minutes early so that you guys are able to to then can be admitted into the session. Okay, happy days, ne?
Happy days, sir.
All right, guys, I'll see you again next time. Shop.
Bye-bye.
Bye.
Thank you, sir.
You're welcome.